Hi, my name is Rebecca Jernigan, and I'm a first-year graduate student at Arizona State University. In this presentation, we're going to explore how we're using structural biology for structure-based drug design in the fight against COVID-19.
The COVID-19 pandemic has fundamentally impacted the world we live in, with almost 30 million cases and approaching nearly 1 million deaths, while leaving many more with lifelong complications.
In this project, we're going to look at how a unique protein, NendoU, could be used as a potentially potent prophylactic drug treatment for those infected with the SARS-CoV-2 virus.
Non-structural protein 15, NSP15, or NendoU, is an endoribonuclease coded for by the SARS-CoV-2 virus. When the SARS-CoV-2 virus infects a host cell, its positive strand genomic RNA will be translated into a negative strand of messenger RNA. On this messenger RNA is a series of uracils called a poly-U tail. Since this long poly-U tail is unique to RNA viruses and not the host, the immune system recognizes it as a sign of infection, signaling for degradation of the virus in macrophages. The function of NendoU was only recently discovered and found to cleave this poly-U tail. Without the poly-U tail, it helps hide the virus from detection.
The objective of this project is to determine the first snapshots and catalytic mechanism of NendoU by serial femtosecond crystallography.
The timeline for this project was incredibly fast-paced, receiving NSF rapid funding and starting in early June. One of the first challenges presented was obtaining enough protein for the mix and inject experiments. Early yields were as low as 0.5 milligram of protein per liter of culture. The yield was slowly increased to 5 milligrams per milliliter, and over 300 liters of culture were grown and purified in less than 3 months. 2 different crystallization conditions were established, one by free interface diffusion and the other by concentrating the protein to 80 milligrams per milliliter in low salt buffer. The crystals grown by FID had a better diffraction quality and were used for subsequent experiments at LCLS. Activity of NendoU in solution and washed crystals were tested with 3 different RNAs showing activity. 12 complete datasets were collected in 5 shifts at MFX with the mesh injector from August 28th to September 1st. In our first look at preliminary data, we can see the apostructure of NendoU to 2.6 angstrom at room temperature by SFX for the first time. Additional datasets were collected using the mix and inject technology with manganese and 2 different RNA substrates. One of the challenges presented was a possible citrate component from the crystallization buffer appearing to sit in the binding pocket. For future experiments, we plan on using new crystallization conditions without citrate and using both cleavable and non-cleavable RNA substrates for binding.
We hope that our findings will be used in the drug discovery pipeline for determining inhibitors of NendoU. Thank you for listening to this presentation, and please pause the video to view the poster.